So in this video, I'm going to talk about how we can find factors of a polynomial using polynomial division. So this is one situation where you would use polynomial division. So let's say, for example, we're given the function, let's say f of x equals 2x cubed plus x squared minus 15x minus 18. Now, if I were to tell you to factor that would be pretty difficult for you to do in the same way that we would factor simpler quadratic equations. So, if I tell you that one factor of this equation, of this function is, let's see, one factor is going to be 2x plus 3. So we know one factor of this polynomial is 2x plus 3. We want to find the other factors. So what we can do is, just like we would if we were to say, for example, I know that, let's see, I know that 4 is a factor of, I'm just going to put this on the side here. I know 4 is a factor of 144. So I'm going to go through this just so we get the idea and why what we're doing works with polynomials. So if 4 is a factor of 144, for example, then if we want to find, well, what times 4 is 144, we can just divide it. So take 144 divided by 4, and we can long divide it. Let's see. 4 goes into 14 3 times. So that's 12, we get 2, and then pull down the 4, and then 4 times 6 is 24. So our answer is 36. So 144 divided by 4 is 36, so that means that 4 times 36 equals 144. So 36 is our other factor that would go with 4 to get 144. It's the same idea here. If we know that 2x plus 3 is a factor of this polynomial, what can we multiply that with to get this polynomial? And we can do that by taking this, dividing it by this, and then see what we get. So same idea as this, but with polynomials instead. So if we do that, we can take 2x cubed plus x squared minus 15x minus 18, and divide that by 2x plus 3. Now 2x goes into 2x cubed, x squared times, we're going to put x squared here. And if you struggle at all with this long division, I have another video covering long division of polynomials if you want to check that out. So continuing with this long division, so we have 2x times x squared gives us 2x cubed. So then we multiply 2x squared times 2x, or sorry, we multiply x squared times 2x plus 3. That gives us 2x cubed plus 3x squared. Then we subtract all of that. So change those signs. And we get negative 2x squared. And then we can pull down the minus 15x. So now what times 2x gives us negative 2x squared? It's going to be negative x. So then we take negative x times 2x plus 3 is going to give us negative 2x squared minus 3x. But then we want to subtract it, so basically we just change the signs. That gives us negative 12x and then we can pull down the negative 18. All right. Now, how many times does 2x go into negative 12x? It's going to be negative 6. So negative 6 times 2x plus 3 is going to give us negative 12x minus 18, but then we want to subtract it, so effectively we just change the signs. And we get 0, which is what we should get because we know that this should divide evenly. So this is what we get. Now, we could say now f of x is going to be equal to, so this was our original polynomial, but now we can say it's equal to 2x plus 3 times x squared minus x minus 6. Now, this could be your final answer depending on what the question is asking. So, on a test, for example, it might ask you to write f of x as a product of linear factors. So, this is writing f of x as a product of two factors. But this factor is linear. This factor is quadratic. This is a quadratic expression. So if we want to write it as the product of linear factors, we have to continue factoring this guy here. So if we do that, let's just write down here that so far we have that f of x is equal to 2x plus 3 times x squared minus x minus 6. Now if we factor this, guy here. Now this is a little easier to factor than this whole thing was. So if you think back to math 2, we can factor this quadratic expression by thinking what multiplies the negative 6 and adds to negative 1. So what's that going to be? We can write out all of our potential, so we can write out our factors of negative 6 basically. So we can either have negative 1 and 6, or 1 and negative 6, or we can have negative 2 and 3, or I'm just going to say positive 2 and negative 3. So which of those pairs is going to add up to negative 1? And it's going to be the positive 2 and the negative 3. So we're going to say x plus 2 is one factor, x minus 3 is the other factor of this guy right here. So now that we've split this up into two linear factors, we have our whole function written as the product of linear factors. So if a test question asks you for the linear factors to write a function like this as a product of linear factors, this is what you want.